Hey guys, we are graphing some logs today. So if you've been graphing things like parabolas, square roots, things like that, you've probably been having a parent graph and then applying any changes you needed to do and graphing your graph. That's what we are doing today as well. Logs are just a tiny bit different, but not too bad. So when we are graphing a log, it will change if there's a number being multiplied in front, whether that number is positive or negative. That will change my graph. If there's something being subtracted from or added to x, that will change my graph. And also if there's something being added or subtracted on the back. You'll see on ours today, the only thing that we have that changes is we have the h. So we have -2. Now, when it's next to the x, that is right and left, and you do opposite of the sign. So this graph is going to be shifted to the right 2. The other thing to take note of is my parent graph will be a little different based on what b is. So in my graph on this one, it is 3, but that could literally be any number. So what we usually do is figure out what our parent graph is based on that number. So we're going to have our parent graph have a 3 as the base. Now we would also like to take into account if there were a number being multiplied out front. There's not in this one, so we don't have to worry about it. So my parent graph that I am going to graph and then shift to the right 2 is going to be y equals log base 3 of x. I'll graph that, shift it to the right 2, and that will be this graph. Okay, when I am graphing these, it's often helpful to convert it to exponential form. Logs and exponents are very connected. If you need a review, I'll link a video in the corner. But if I write this in exponential form, it's going to be 3 to the power of y equals x. Now I haven't changed anything, I've just written it a different way. If you were to graph both of these in your graphing calculator, it's the same graph, okay? It's just a little easier sometimes for our brains to think of it this way. Now we're just gonna make a table and plug in some points and see what we get. So often we plug in numbers for x and get y. Since y is the exponent, it's going to be easier to plug in numbers for y and get x. It might feel a little different than you're used to, but it's totally math legal. So a lot of times what I like to plug in is -1, 0, 1, and why not? We'll just do 2 as well. This can sometimes be on preference. You just want to pick points that'll help you understand the shape your graph is taking. So if I plug in -1 for y, I'm going to have 3 to the power of -1. Now, whenever I have a negative exponent, we just drop it down to the denominator. So it'll be 1 over 3. If that felt crazy, I'll link a video in the corner explaining why. So when I plugged in -1 for y, I got 1/3 for x. When I plug in 0 for y, 3 to the 0 power, well, anything to the 0 power is 1. Again, I'll link a video explaining. If I plug in 1 for y, I get 3 to the 1st, which is just 3. If I plug in 2 for y, I get 3 squared, which is 9. Now, obviously, we could plug in points forever, but this is going to give us a good idea of what our graph looks like. So this, remember, is my parent graph. This is the log base 3 of x graph. So I'm going to graph it in pencil because it's not my actual graph. I got to shift it to the right 2 to get this graph. So I've got 1/3 -1. So 1/3, kind of guess where that is. It doesn't have to be perfect. It's going to be around here, down 1. 1, 0. 3, 1, and 9, 2. Okay, that is my parent graph. Looks a little something like that. It's going to get closer and closer to the y-axis, but never actually touch it. That is my asymptote. So the asymptote on my parent graph is x equals 0. All right, Now to get this graph, all I have to do is shift this graph to the right 2. So I'm going to take this point, shift it to the right 2, this one to the right 2, 2, and this one's going to go off, but it'll be approximately right there, right? Okay, another thing that also shifts over is my asymptote. So my asymptote was at 0. It's also going to shift over 2, and my asymptote is going to be at 2, right there. So now my graph is going to look something like this. There we go. One note to make is if you have been graphing exponential equations, you may notice that they are inverses of each other. An exponential graph goes like this. So if we had graphed y equals 3 to the power of x, it would look something like that. Okay, now you may want to erase your pencil graph if it's distracting, kind of up to you, but there is my graph. Now we may also want to identify the domain and the range. That's just something, you know, we like to do in math land when we do graphs. So the domain is my x values. So what can x be? Well, x can be anything bigger than 2, right? If I try to plug in negative numbers or 1 or 2 for x, it's not going to work. I'm not going to get an answer. So my domain is x is greater than 2. My range is my y values. Well, we're going down forever and slowly up forever. So my range is going to be all real numbers. You could plug in any number for y and get an x. And then a lot of times we also like to identify our asymptote, which we already talked about is x equals 2. Okay, we did it. I hope this was helpful. If you are in need of more examples, we'll have negatives, we'll have fractions, we'll have things being added or subtracted on the back, all sorts of fun things. If you need any of those examples, I will link a playlist in the corner for you. Thanks.